Hello friends, welcome to my YouTube channel. Friends, today we are going to discuss a numerical problem based on the SN curve with the second method. In the previous lecture, I have solved this numerical problem with a different method, and today we are going to use a different method. Friend, the data is given as a cylindrical shaft is subjected to an alternating stress of 100 megapascal, and the fatigue strength corresponding to 100,000 cycle is 490 megapascal, and the corrected endurance limit is given to us as 70 megapascal, and we have to estimate the shaft life in number of cycles. Now friend, I have plotted or taken this data in a tabular form and write down as shown here. Now friends, see, corresponding to 490 megapascal, that is the stress amplitude, the number of cycle of failure is 10 raised to power 6, and corresponding to 70 megapascal, the number of cycle of failure is 10 raised to power 6. Why? Because as the corrected endurance limit is 70 megapascal, that's why I have taken the number of cycle of failure as 10 raised to power 6, which is always 10 raised to power 6. And the next thing is that when the stress amplitude is 100 megapascal, then we have to find out the number of cycles. So friend, in this video we do not need to take these log terms, that we need not to calculate the log of these s value, that is the stress value, and log of these n values. We will use a direct method, which is a formula based method. In this method we use a formula which is given as s is equal to a n raised to power b, where a and b are constant and n is the number of cycle corresponding to the failure, and s is the stress amplitude, where s is the stress amplitude and n is the corresponding cycle of failure. Now friend, we will make equations. Now in the first case, our stress amplitude is 490 and the number of cycle of failure is 10 raised to power 3, that is 1000 cycle. So that's why I am writing 1000 raised to power b, that is putting the value of this and this in this equation, and this is our equation number 1. And in equation number 2, the s is equal to, again writing s is equal to n raised to power b, and the value of s is 70 megapascal. So I am putting the value of s as 70 megapascal here, and the value of a is written as it is, and the value of n is 10 raised to power 6. So I am writing 10 raised to power 6 here, raised to power b. So this is our second equation. When I solve these two equations, I will find the value of constant a and b. A and b. Now the value of constant a and b can be found out very easily. I will divide the equation number 1, equation number 2. So dividing equation number 1 with equation number 2, I will get 490 divided by 70 is equal to 10 raised to power 3 divided by 10 raised to power 6 whole raised to power b. A will cancel out here. That is dividing first by second. Okay friend, so I will get this equation, and when I will calculate the value of b, I will get a value of b is equal to how much? Minus 0.2816. This is the value of b. That the value of b is calculated using the formula that we have to cancel out the 10 is to power 6 with 10 is to power 3. How? Let us see it. So dividing this by 490 by 70, we will get 7, which is equal to how much? 10 raised to power minus 3b. Okay, and when we take log of this term, that is, this implies log of 7 is equal to minus 3b log 10. This is log base 10 and log 10, that is taking log of this equation on both sides, we will get this equation, and we will, when we solve this equation, we will get the value of b as this. So this is the first step of getting the value of b, and once the value of b we have taken, the next step in the design procedure is to calculate the value of a, and when we substitute the value of b in any of the equation, that is the equation 1 or equation number 2, we will get the value of a. So substituting the value of b in the equation number 2, that is 70 is equal to a 10 raised to power 6 b, substituting the value of b here, we will get 70 is equal to a 10 raised to power 6 b. B is how much? B is minus 0.2816 taken from here. Okay, so we will calculate the value of a here. So the value of a will come out to be how much? 3420.566. so we have calculated the value of constant a and constant b. So both the constant a and constant b are calculated. In the next step we will write the equation again. So when we write the equation again for the stress, that is this equation, a n raised to power b, so s is equal to a n raised to power b, and putting the value of a and b, the value of a is 3420.566 here, taken from here, and the value of n is writing as it is, and the value of b is minus 0.2816, minus 0.2816. okay, so this is the value of a and this is the value of b. Now we have to find out the number, estimate the shaft of life corresponding to 100 megapascal stress. So corresponding to the 100 megapascal stress, writing down the value of s as 100 is equal to 3420.56 is the number of cycle we have to calculate. So number of cycle will be 2. When you solve this equation, you will find out the value of this n will come out to be how much? This will come out to be 275422, and this will be the value of n. So this is the method, second method of finding out the value of n. So the corresponding to the 100 megapascal, the number of cycle of failure is 275422. So this is the method to calculate the number of cycles. So this is the another method of solving the problem regarding SN curve. So friend, if you like my video, you can subscribe to my channel and press the bell icon for further videos. Thank you friends.